let's do a quick review on how to rationalize the denominator. Now, there's two types of rationalizing the denominators. You have when there is one term, so something like 4 over the 5th root of x to the 3rd. Or you have something like 5 over 3 plus the square root of 7. In that case, there's two terms in the denominator. One term that will be a rational number, and then another term that will be an irrational square root. So each one of these has a different process for rationalizing the denominator. So let's start by looking at how to rationalize the denominator when there's only one term. This is actually the harder of the two methods. So when you have one term, let's just go something like that. Actually, let's just do x. So what you want to do is you want to start by looking at the denominator and writing everything under the radical as its lowest base that you possibly can. So in this case, I would want to write this 4 as 2 squared because 4 is not a very low base, so that's okay. You can do this with 4 to the first. But in order to save yourself some kind of difficult simplification in the end, it's easiest to take this number right here and just write it and see, is there a base that is lower that I can rewrite it as an exponent? In this case, 4 is 2 squared. If you had 8, you could write that as 2 to the 3rd. If you had 64, you could write that as 2 to the 6th. So write them as their lowest exponent base. Okay, then we really only have just x to the first here. Now what we want to do is we want to multiply our denominator by something that will allow us to cancel out that exponent and the radical. So what I'm looking for here is I want to make this 2 to the 2nd, 2 to the 3rd. So I need to say how many 2's do I need to multiply that by so that it is 2 to the 3rd. In this case, it would be 2 to the 1st. And then the same thing with the x's. I have x to the 1st, but I want that to be x to the 3rd. So I need to multiply that by x squared. Now I can't just do that though. I can't just multiply that denominator and be good with that. In order to make this process work, we have to multiply the denominator and the numerator by the same thing, because that's what 1 is. That's a form of 1, and you can multiply anything by a form of 1. Now we can't just cube both sides of the equation because cubing something is not a form of 1. Okay, so it has to be multiplying an entire equation by the numerator and denominator, and that is 1. Okay, so let's write that here. This is a form of 1. Okay, now once I've done that, my numerator just multiplies across here. And then in my denominator, I have the cube root of 2 to the 3rd because of the product rule. And x to the 1st times x squared is x to the 3rd. Everything is to the 3rd power. So because of that, we can cancel those denominators out. So in my denominator, I just have 2 over x. Now, it is important to note that you cannot cancel that 2x with what is inside the radical, because in terms of order of operations, that radical needs to be done before the division can be done. So The only thing that can cancel is if there was anything outside the radical that would simplify. In this case, there is not. So then this is our final simplification, where we no longer have a radical in the denominator. Because rationalizing the denominator simply means get the radical out of the denominator. So we've done that, and we are good. Everything is simplified. Now let's take a look at what happens when we have two terms in our denominator. Okay, so let's say we have, I can't remember the one I put on the bottom, so I'm just going to come up with a new one. 4 over 3 plus the square root of 7. Okay, so when we want to rationalize the denominator when there are two terms, it is important to know that our radical has to be a square root for this to work. If it's not a square root, then this process does not work out. Okay, so we have 4 plus 3 square roots of 7, or 4 over 3 plus square roots of 7, sorry. We want to get that radical out of the denominator. Well, there's a special term here called a conjugate. And when we multiply conjugates, the radical goes away. A conjugate is just the opposite sign between the two numbers. Now, you don't change every term sign, you only change the sign in between the two numbers. You might know that as the difference of the squares when we talk about foiling or factoring a squared minus b squared, which would be a plus b times a minus b. When we multiply conjugates, you only have to go the first and the last terms. The last terms, square root of 7 times the square root of 7 is 7. So here we would have 9 minus 7. If we were to multiply the inner and the outer terms, we'd have 3 square root of times negative square root of 7 and 3 times positive square root of 7, which actually cancel out. So keeping that in mind, if I want to rationalize the denominator, what I need to do is just multiply the top and the bottom by the expression that would cancel the denominator out of my, or cancel the radical out of my denominator. So here I have 3 minus the square root of 7. All right, now we will do that. I actually think it's easier to distribute that 4 through after I FOIL my denominator because, well, we already know what this is FOIL. Let's just look at it one more time. The first terms is 9. The outer term square root of 7 times the square root of 7 is negative 7. And that becomes 2. Now, I didn't distribute my 4 through, and I'm actually very grateful for that because the 4 is being multiplied by that parentheses we can cancel. So the 2 and the 4 reduce. And my final answer is actually just 2 times 3 minus the square root of 7. Or you can write that as 6 minus 2 square roots of 7. And there we go. So rationalizing the denominator when there's two terms, it's actually a nice process. It's always the same process, and it's just multiplying by the conjugate. When we're rationalizing the denominator when there's only one term, we kind of have to just go through and balance, and that's a little bit harder to figure out what we need to balance. But in this case, it's always just the conjugate. So there you go. That is rationalizing the denominator with one terms or with two terms.